Hello, everyone. Today, I'll be talking about a fascinating and fast evolving field at the intersection of machine learning and cybersecurity. Adversarial machine learning, or AML. With the increasing use of machine learning in cybersecurity for tasks like intrusion detection, spam filtering, malware classification, and fraud detection, we are also seeing a new set of threats that aim to exploit these very systems. These threats are not traditional malware or phishing scams. Instead, they are smart, subtle, and often invisible to human eyes. They are called adversarial attacks. In simple terms, adversarial machine learning is the study of how attackers can manipulate machine learning models either during training or after deployment, and how we can defend against those manipulations. It's about making ML systems more secure and robust in the face of intentional malicious inputs. Let's break it down with a simple example. Imagine you've trained a model to detect spam emails. Over time, it gets good at identifying common patterns like suspicious links, non phishing keywords, or strange formatting. But a hacker, knowing how your model works, begins to slightly modify the structure of the email, changing a few words, replacing characters, or obfuscating URLs. Just enough to fool the model into thinking it's safe, while still tricking a human recipient. That's an adversarial input, a carefully crafted input that causes the model to make a wrong decision. There are mainly two phases where adversaries can strike: training and inference. Number one, poisoning attacks. These occur during training. The attacker injects malicious data into the training set to correct the learning process. Imagine training a facial recognition system with a few fake faces labeled as someone else. The model learns this mistake and later misidentifies those fake faces. Number two, evasion attacks. These happen at the inference stage, after the model is already deployed. Attackers make tiny, almost imperceptible changes to input data to bypass detection. For example, adding a small amount of noise to a malware binary so it evades a malware classifier. Number three, model inversion and extraction. Here, attackers try to learn about the model's inner workings, sometimes even reconstructing the training data or copying the model itself by repeatedly querying it. These methods show how fragile machine learning models can be when facing intelligent attackers. Cybersecurity relies increasingly on automated systems to detect threats in real time. Whether it's detecting malware, phishing attempts, or network intrusions, machine learning is doing the heavy lifting. But if attackers can reliably fool these systems, then the entire foundation of modern cybersecurity becomes shaky. Let's take the example of malware classification. Suppose you have a model that classifies software as benign or malicious based on code features. Adversaries can apply code obfuscation techniques or add benign looking dummy code to fool the model into classifying malware as safe. This is already happening in the wild. Another example is CAPTCHA solvers. Machine learning models used to generate CAPTCHAs can be reverse engineered using adversarial examples, making it easier for bots to bypass them. In biometric authentication, adversaries have created adversarial eyeglasses or masks that can trick facial recognition systems into misidentifying users, posing a real world physical threat. Now that we know the risks, what can we do? There are several defense strategies being developed, though none are foolproof yet. Number one, adversarial training. One popular approach is to retrain the model with adversarial examples so it learns to recognize them. This can improve robustness but also requires a good understanding of the kinds of attacks that might be used. Number two, Input sanitization. This means pre-processing or filtering inputs to remove potentially harmful modifications like noise removal or code normalization. Number three, model hardening. Techniques like gradient masking or using robust architectures can make it harder for attackers to craft adversarial samples. But these methods can sometimes reduce model accuracy. Number four, detection systems. You can also create a second layer of models that specifically detect adversarial inputs and raise alerts. Still, it's a cat and mouse game. As defenses improve, attackers get smarter. This is why adversarial machine learning is not just a research field. It's becoming a cybersecurity necessity. As we move forward, it's essential to think about machine learning models not just as statistical tools, but as potential targets. Just like any server or database, an ML model can be attacked, manipulated, and exploited. We need better testing environments, robust benchmarks, and more cross disciplinary collaboration between cybersecurity professionals and AI researchers. Also, regulations and standards will be key. Just as we have guidelines for secure coding and software development, we'll need secure practices for training and deploying ML models. To sum up, machine learning is transforming cybersecurity, but it's also opening new attack surfaces. Adversarial machine learning helps us understand and defend against these new threats. While it's complex and evolving field, awareness is the first step. As professionals in cybersecurity, that we must recognize that AI systems are not immune to attack, and our job is to anticipate, analyze, and adapt. So, this was about adversarial machine learning in cybersecurity. I hope it was helpful for all of you. And until we meet next week with another topic, please stay safe and stay secure.